In this video clip, we will go through some of the different ways that the general model may be used to split flows from a tank or a tie. In this example, we have 5 streams connected to a tie. If the splitter option is not enabled in the tie, then the flow from the tie will be split evenly between the 5 streams. As you can see here, where there's 100 kilograms per hour coming in if 001, and it's split between the 5 streams so that each stream gets 20 kilograms per hour. To enable general model in a tie or in a tank, on the first page, near the bottom under Options, there's this field called Split Flows. If I tick that field, you'll see I get a new tab called GM, which stands for the general model. If I click on the GM, you'll see the default method of splitting is mass fraction, and here you'll see each of those 5 streams, P1 to P005, all shown. Now you cannot control all the streams from a splitter, because one of the streams must be free to balance the flows. So in this example, we cannot set the flow from stream P005 here at the bottom. SysCAD always forces the stream at the bottom of the list to be the free stream that you cannot set. If you want to set the stream that's at the bottom of the list, then you must change the priority. Each of these streams has a priority, and you'll see P01 has priority 1, it's at the top, and all the others are auto. If I want to control P005, on the drop-down arrow, I go and change priority from auto, say to 2, and you'll see it's now blue. I click on the OK button, and it pushes P005 to the second stream on the list, which I can now go and set the flow that I want from that stream. And you'll see P004 has now dropped as the stream that I cannot control. So that's the way that you can make sure you can control streams. I'll change P005 back to auto and click the OK button, and you'll see it goes back down to the bottom. So let's have a look at how some of these different methods work when you want to control a split. So the first one, as we can see, is mass fraction. So I can go and set the different mass fractions. So for instance, I can say I want 10% to P001. Let's leave 50% for P002. Let's say 5% to P003 and 0 to P004. I'll click on the OK button, and then if I push run, it solves, and here you can see what's happened. So our feed in is 100 kilograms per hour with the different makeups. There's some vapor, solid, which I've given one of the solids that is flowing there, SiO2, liquids, and then the liquid is divided into aqueous and organic. You'll see I've got 40 kilograms per hour total of liquids, which is made up of 30 kilograms of aqueous and 10 of organic. Now I've got 10% to P001, 10%, 50 to P002, 5 to P003, 0 to P004, and the remainder, which is 35, goes out of P005. Okay, so that's the mass fraction, how that would work. Let's have a look at what other options we have. So if I click on the drop-down arrow, you'll see there's a whole list of the options that we can use. So we've used mass fraction. If I change it to mass flow, now I can set the flow that I actually want going out of each of the streams. So if I said P001, let's leave that at 0 kilograms per hour. Let's say we want 80 kilograms per hour from P002, 10 from P003, and let's ask for P004 more than what we can get. So let's say 50 kilograms per hour. Now we know we only have 100 kilograms coming in, so we know we're not going to be able to satisfy that. Let's see what happens. So if I push run, we'll see that we've got 0 to P001, 80 to P002, so we've satisfied that. P003's got 10, but all that's left is 10 for P004. And to see here, we've got an error, QM error, of minus 40. So it's tried to give it 50, and it's got an error of minus 40. Plus, you can see the product splitter itself has gone orange, which is indicating that there is a warning there. And we'll see up here, we've got one warning. If I click on that messages button and I go to the solver conditions, you'll see the product split, GM requirements not met in one stream. So that's what SysCAD will always do if it cannot meet your split requirements. So if I change that back down, let's say just to 5, which we know we can satisfy, and we say OK, and now I solve, you'll see that error has gone away. It's no longer orange. I have no errors up there, and we've got 5, and the remaining 5 goes out of P005. Okay, so that's mass fraction and mass flow, and you'll see there's volume fraction and volume flow, which operate in the same way as the mass fraction and the mass flow. So I'll leave that for the moment. Let's look at phase mass fraction. So here we go. And for phase mass fraction, you can either set the total phase or the individual. Let's start with total. So if I click on total there, you can see I can set the phases that must go through each stream. So let's take all of the gases out of P001. And then for P002, let's take, say, 10% of the solids and 5% of the liquids. So a bit of a mixture in P002. P003, let's just take 80% of the liquids. And P004, we'll say 100% of the solids. I say, okay, now SysCAD is doing this sequentially. So it does P001 first, then 2, then 3. So when we say 80, it's only allowed us to take 90% of the solids because we've got 10% going into P002. So if we push 1 now, we'll see what happens if we have a look here. P001 has all the vapors, so none of the other streams have any vapors going out of them. P002 has taken 10% of the solids, so our solid flow is 40, it's got 4, and 5% of the liquids, 2, so a total of 6. P003, 80% of the liquids is going out of there. You'll see there, 32 kilograms per hour. P004 has only solids, so we've asked for 90%. And that's all the solids now because 10 plus 90 is 100, so we've got nothing going out of P005, and P005 is taking the remainder of the liquids. So that's our phase mass fraction. And the phase specification is total. In other words, the total of each phase. But we can now change that and ask for individual. And you'll see what happens here is we can actually split between liquid, organic, and the aqueous forms. You'll see here we've got aqueous flow of 30 and organic flow of 10. So here we can actually split between the individual phase fractions. So let's leave P002 with 20% of the solids. But here with P003, let's have a look and split. We'll take 0 organic and we'll take 50% of the solids. And here for P004, let's take 100% of the organics only and no aqueous. So we'll leave it as that, push run, and let's have a look what that looks like. So you'll see in P004, it's taken all the organics. No aqueous, but just the organics. So this way, you can use the tire to even split between aqueous and organic. So that's phase mass fraction, both total and individual. And you can also have phase mass flow. And that we can only look at total, or the total of each phase. So here I could go and I could say I wanted 10 kilograms per hour of the vapors going here, 5 of solids. Let's have a nice mixture. Take 5 of each of them. And let's go for 30 here of solids. If I just push OK, if we run, you'll see we've got 10 kilograms, 5. So it's actually taking the flows that I asked for there of each phase. And the phase volume flow is the same, but just you set your volumes. Species mass fraction, if I click on that one, you can actually say set amount of species going through each stream. Now I'm not going to set these all up. You'll see because it's actually quite a lot of work to set each one up. You can see for each stream I can say how much species. But let's just set up for P001 and I'll say for this one I want, let's go for in the organic, if I say I want 100% of that ROH. Well, actually I've got this, and now if I say run, you can see P001, there we go, it's taken the organic there. And in fact, because I didn't set any of the other streams, all of the remainder goes out of the free stream P005. So the species mass fraction is quite a useful thing if you want to separate out just a single species. And the last one we want to look at is general. So with general, you can use a combination of your different operational types. So for instance, for P001, we can say phase split, and I want to take all the vapors out of there. For P002, I want to say I want a mass flow. I want 80 kilograms an hour, and I want that to be 100% solids. Okay. And then for P003, I can change it. Instead of mass flow, I can say I want that to be phase split. And here I can say I want the liquid 80% of that. So you can mix it up if you use the general. If I click on OK and push run, you'll see all of the vapors have gone out of P001 as expected. P002, I've asked for 80 kilograms an hour of 100% solids. Well, it can only have 40 because that's as much as there is. So it's taken all of the solids and it's showing me an error of 40 kilograms an hour. So let's go change it down, say to 30 to get rid of that error and say run. And now we've asked for 30 kilograms per hour, 100% solids, and there it all is running there. So the general is actually quite useful in setting this all up. I hope that's helped you in seeing how you can set up a general model to split streams in different ways.